Hi friends, I'm Andrew. This is Code Gets Creative. Welcome to part 7 of Lightblocks. I think if everything goes according to plan today, this is going to be kind of a short stream, and this is going to kind of wrap up this early version of the Lightblocks program. There's still plenty of things that we could do with it, plenty of like new blocks we could create, plenty of like new cool functionality that it could have. But for now, like this is a really, really strong MVP, and we can start to like put this in people's hands, and we can definitely make really cool light shows with it. So last time was all about polishing and doing things like getting the README looking good, getting the code cleaned up a little bit. Today is all about publishing. And remember that the ultimate goal has always been, let's see if we can get this to focus. We want to run this bad boy on a Raspberry Pi computer. So this is a Raspberry Pi 4 Model B. You can see it right there. Little fan going on in the case. And so today, if everything goes according to plan, we're going to get things running on this. Let's look at what we have done since last time and since kind of some work in between the streams. So here is our homepage for the repo. This is github.com/AndrewJensen/Lightblocks. Let me chuck that into the chat. There we go. So that's available. Notice how we've got our cool screenshot, so you can get an idea of what this thing's actually going to look like, how it'll behave. I think later we can add like a cool GIF that's got like lights going on in the background. We talk about the project. We talk about how to set it up, right? And at the end of the stream last time, we had just option 2. Option 1 didn't exist. But option 1 is now working. I went ahead and did a bunch of cool Docker stuff so that now this thing actually works. So Docker images are building, they're getting pushed, and so you can use this. So let me give you a quick demo of that, and I can walk you through how the Docker file works, and then also how GitHub Actions works. So the process of actually building new Docker images is automated every time the code gets pushed to master. So yeah, let's look at that. By the way, I've got my to-do list as always. So for today, I want to review that stuff that I just mentioned. Right, we'll look at the image, we'll look at the workflow. Then we need to actually publish a multi-architecture image. We'll talk about what that means. Basically, it's like you got to run it for different kinds of processors, and then we'll actually run it on the Raspberry Pi. We'll SSH in and do all the fancy stuff to run the image on the Raspberry Pi on the network, and we should still be able to control all the things. Let's find out. So let's look at the, let's actually run this bad boy. Run the image. So you'll notice in my little notes page, I've got the instructions for myself to build, which I've already done, and then here's Docker run. So when I run this very tall bash command, what it's going to do is, you can see it's Docker run, do it in interactive mode, clean up when it's done, expose port number 4000, set these 4 environment variables. So you can see these 3 are all about, these 3 are all like credentials to actually control Philips Hue lights. And then this one is, hey, we're running in production mode. And this one is really important. This creates a Docker volume. So it says, hey, this is a directory where you're allowed to put the database file. And so that way we can create a database when we first start up Lightblocks, but then when we shut down Lightblocks, that database file will still exist. So we can turn Lightblocks back on later and reboot it from the same database state that it was in before. That line's super important. And then last but not least, what's the name of the image. And so it's adj90/lightblocks. That's what it's published under. Okay, so let's give this a try. And I'm going to swipe over here. Notice how I also have Docker Desktop running. You can see I'm running on Mac OS. It might look a little bit different for you if you're running on Windows or Linux. But what we're going to do is we're going to run that command in the terminal, and then we'll see it pop up here as well. So here we go. And you'll notice that all of this console output is the same that we saw before. That's cool. It says the server's listening. And now it has auto-generated a name for me, elastic : and it's using that image. And if I navigate there, you'll see the Lightblocks is running. I've already created a database file. Let's see, you'll notice it's like users, Andrew Jensen, desktop, tempdb, and that was a directory I created on my desktop, and then I've already started this up once before the stream started, so it created a SQLite file. I've created my cool test. I click edit, here's a program, click run, and we've got color changing lights, so things still work. Let's prove that like persistence still works. So we're gonna like shut down the image and then bring it back up. We'll see that our image saved everything, or our database file saved everything. So now it's purple, right? If I refresh, oh, okay, we found a bug. We can fix that later. But let's see. Go over to here. Yeah, you'll notice that has saved, right? Yeah. That bug that we just saw has to do with React Router and React Router settings. So we can, yeah, fix that. Okay. Here the image is running. So I'm going to go over here. I'm going to delete it, stop it and delete it. But this does not actually delete the database file. So I can say list everything that's in tempdb, and you'll notice this lightblocks.sqlite is still there. So if I run that same command as before, it'll think for a minute, connect to all the things. And you can see that everything came back from the same state. So we've got this magenta purple color. There we go. Cool. So that's that. We can actually run it. Let's shut it down so my computer doesn't have to work too hard. I'm worried that I'm gonna drop a bunch of frames. Yeah. Okay, I'll put that away. And as a matter of fact, I think I'm actually done with Docker for now. So I'm gonna quit this. We might glitch just for a minute. But yeah, this means that my computer will not have to work quite as hard once that's quit. Okay. So yeah, let's talk about how we actually did that. And there are two files we care about. File number one is this Docker file. You'll notice it's right on the root. The other one that we're going to look at is this publish.yaml. We'll get to that in a minute. So what is a Docker file? Docker file is it's this kind of static file that describes step-by-step instructions for getting an environment all set up that's containerized. So it's like a tiny little mini virtual machine, a tiny little instance of Linux running inside of your computer, whatever that might be. And it is going to run each of these instructions that you see, each of these commands that are in blue. It's going to run one of those, and that's going to create a layer. It creates kind of this like onion of layers of, you know, like the base image. In this case, it's Node version 12.22.3 running on Alpine Linux version 3.14. So we'll start from that. That's the core of the onion. And then we'll say, hey, our working directory is user source app. So all of our code and stuff is going to end up in that directory in the file system. Then we're going to say, hey, grab server/package_star.json and copy it into our working directory. So this is like copy from the host machine into the container. We do that once for the server, once for the UI. We'll talk about, you'll notice that there's some copy commands here, and then there's one more copy command here. In between there though, you'll notice that we're saying go into server and then run npm CI. npm CI is basically npm install, but it says don't try to update anything, just use exactly what's in the log file. We do that. Then we say, hey, copy the whole directory out of the host computer into the container. The reason that we do this, and then we later come back and do this, is for layer caching. So basically, Docker is really smart, and it looks at these two commands, and it says, since I built the last time, these two files haven't changed. So I can actually just reuse the cache version of that layer rather than spending the time to copy these in and then run these really long, slow commands to download everything. So it speeds it up quite a bit. This all gets kind of mashed together. Then we copy this over. Usually we will not be able to rely on the cache for this because our code will have changed. So we'll copy the code in, and then notice how we say go into the server, npm run build. Go into the UI, npm run build. And so now at this point, we've compiled everything, right? Because we're using TypeScript and JSX for React. And so at this point, it's vanilla JavaScript that's ready to be executed. And this right here says, hey, expose a volume, meaning like expose a little chunk, a little like mini file system. And that should be called /db. So inside of the containers file system, /db is going to exist. We say expose 4000. So that means that the computer's port, the container computer's port number 4000 is opened up, ready to receive incoming traffic. And then last but not least, we say cmd node env equals production node this. And you'll notice that this is pretty similar to the package.json that's in the server. So when we say npm run serve from last time, there's that very same thing, with the exception of node env equals production. So we're forcing it into production mode. Cool. That's that. And you'll notice like npm run build, that's of course hitting this, which runs the TypeScript compiler. That's how that works. When that gets created, we end up creating a Docker image locally, and then we can say Docker push, and we can push that up to what's called Docker Hub, which is it's the big public registry of everybody's Docker images, however. And so that's where mine happens to be published as well. And you'll notice that I have this edit to readme.md waiting to go in. That's a link to it. So let's go check that out now. If we go over there, here is the Lightblocks image right there. You can go to tags, you can see the latest, and it says, hey, the last poll was 35 minutes ago, and it was last pushed 35 minutes ago. So that's when I did that. When I was getting all set up. Cool. And this is so great because now anybody that wants to run Lightblocks, they don't have to necessarily have Node.js installed. All they need is Docker, and Docker is this kind of generic, virtual machine runner, container runner. And so it really simplifies all the steps that you need to do in order to actually set up your host computer to run whatever app it is. This is a great way to actually get our app into the world. Okay, so we looked at the image. Now let's look at the GitHub workflow. And that's the piece that actually automates running the Docker build command. we'll open up this guy, .github workflows publish.yaml. Yeah, this is GitHub Actions. GitHub Actions is a type of a thing called continuous integration, or CI. And continuous integration basically means you can automate kind of these mundane aspects of your workflow so that they just happen whenever you make a change. So whenever code goes to the master branch, or maybe whenever you create a Git tag, eventually we want to do that on Lightblocks so that we're only updating the Docker image when we've got like version 2, version 3, etc. We can do it on that. But what it does is it runs a job. You tell it, hey, run on the latest version of Ubuntu Linux, and then it has steps, right? And so each of these steps is gonna perform some kind of action. So notice how this just checks out the code, and then it says, hey, use Node.js. So it's actually installed Node on that CI runner, which coincidentally is probably running Docker. Kind of cool. So you say, yeah, run setup Node. It should be this version of Node. Then we set up QEMU, which is quick emulator. This is going to allow us to do multi-architecture builds. And we say set up Docker build X. Build X is like the new Docker build. It will let us do multi-arch builds. So that's cool. Multi-arch, whatever. I will mix and match those all night. And then we log into Docker Hub. Remember that's did I already close it? I did. Oh well. That's where that image is hosted, right? So notice how we're running this like login action for Docker, and the username and password are secrets.dockerhub username and secrets.dockerhub token. And so those are actually saved as secure secrets inside of the GitHub repo, and they're not part of the code. You won't find them like in here. But when I go to here, I can actually get to it within settings. And so if you set up a project like this, you'll be able to do this too. You can make this secure so that anybody that's looking at your open source project, they won't be able to steal your credentials to Docker Hub, but they will be able to understand how things are working so they can contribute to it in meaningful ways. Okay, this is where really like the magic happens. So we say Docker build push action v2. You say yes, please push it. And then the tags are 80J90 Lightblocks. And then this is a tag called latest. So we're basically saying, hey, this is the latest version of the Lightblocks image. So keep all those other ones, sure, but like this new one that I'm pushing up, this is the latest one. So that way when somebody says, hey, Docker run 80J90 Lightblocks, this is the one they should get. Like this brand new one that you just pushed up, that's what they should pull down. Boom. This last step, image digest, actually just runs a bash command. So it says echo, and then steps docker build outputs digest. So basically, docker build. Let's see, what does that actually create? This, I wonder if this is a misnomer now. No, I think we're good because this passed last time. So basically, like each of these steps will have outputs, and so when we build this guy, we're going to end up with several different output variables. One of them is called digest, and so we'll print that out, and that can help with debugging and making sure everything's good. Cool. Let's actually try it out. So I've made these kind of small changes to the README. I think this one's especially important though, so that they can like easily see the Docker Hub stuff. So let's go ahead and we will commit this stuff. Let's see, add link and instructions to README. So we'll push that up. And then we're gonna run over to here, to the repo. If I refresh this, notice how we've got the latest commit message right here, right? We can see that up here in these two places. Notice this though. There's this little yellow circle right here. Right, you see that? And what that means is that there's an action currently running. Some checks haven't completed yet. So there's this publish/build. I'm going to click details, and this is going to show us the steps that are running. You'll notice that, let's shrink some stuff down. You'll notice that it's already run a bunch of stuff. It's really fast. And so, yeah, it looks like most of these have only taken a few seconds. Build and push Docker images is the really important one, right? Because this is the one that actually like creates this thing. You'll notice there's all this output. And now at this point, we're starting to see all of this output for, let's see, it keeps auto scrolling, pardon the auto scroll. So notice right here, we've got like all the, I just finished? No, it's just still going. Can I turn that off somehow? Maybe I can do this. No, that's not what I want. But basically, we've got all these steps, right? So this is like from this image. That's this step. And then we say work dir. That takes half a second. Copy some stuff. Copy some more stuff. And then run npm CI. Oh, that just finished. Cool. Man, sorry about all the jumping around. That's kind of irritating. So we've copied that stuff. Basically, like, notice each of these commands matches what's in the Docker file. So we can get a really clear picture of how long everything is taking. For example, it took 21 seconds. Come back. Took 21 seconds to build the UI code. To npm CI or npm install the UI code. That's all running. Aha. And so notice how what it just did, it is finished build and push Docker images. So let's scroll all the way to the bottom. And we've got, exporting to image, pushing layers. We're doing all that. And then that's done. Then at that point we say image digest. Oh, hey, we did break that somehow. Nice, okay. That's embarrassing. Full disclosure, I did actually copy publish.yaml out of another project of mine, and I made some tweaks that, like, this is probably not valid anymore. Docker build, I wonder what that should be called. I don't know. I think I don't care enough to fix it tonight, just because we're doing the stream. So I think I will probably come back and make a tweak to that. This totally isn't necessary for, for actually automating your stuff. You just grab this digest here. But yeah, I'll go back and tweak that when it's time. So when everything here is done, notice this green check mark that appears. That means that, hey, every step in this pipeline has succeeded, so I did what you asked me to do. I can also click here and I can see the history of each time that this gets run. And so here's the very first time that I did it, right? And then here's what we just saw together. And we can see how long it takes. So that gives me an idea of, like, should I go get a drink of water or not? Answer is yes, stay hydrated. But yeah, we've got all this stuff right here. And since we're thinking about it, we can even come back to the home page. This is, of course, updated. So this was updated even before the workflow was ran, right? But now we can go here and we'll be able to see the updated version is now on here. So updated 2 minutes ago. We'll go over to here. Yeah, last push 2 minutes ago. So that looks great. Cool. All right, we can check this off. So you're caught up to all the stuff that I've done. Here, we'll switch over. So we're caught up to all the stuff that's kind of been built before here. So now we want to build and publish a multi-architecture image. And I've got a couple of resources open for that. I think it'll be pretty quick. And then we're going to run it, get my visual aid. We're going to run it on the Raspberry Pi. And I've got, I think, everything kind of pre-set up for that step as well. Okay. Let's publish a new fancy image. So, let's see, where is it? Buildx. Yeah, I remember finding this one. This is the GitHub action that we're running, right? So we set up buildx, and then later on, we actually do a build. You can see like setup QEMU, setup buildx. Oh, look at that. So that's just shelling out to Docker build buildx, or will run buildx. Cool. But notice this use right here. So right here, this person is basically like, hey, this should work with multiple platforms. Somebody's like, you have to use this, which we have done. And then, yeah, it's that last comment. But use is to select the builder to use. Oh, so I'm not allowed to do that. Use input. The builder action. Just select the builder to use. Oh, so I can't actually do that. Okay. I misunderstood that. So let's run over here. You can build multi-platform images using the platform's input as described below. Build push action v2. Oh, nice. So it's not even the setup buildx action. It's actually the build push action. It's on v2. Yeah, we're also on v2. Perfect. So let's just snag this. And let's see, we need to figure out what we're actually building for. My understanding is that we need AMD 64, that's your standard. But then we also... Yeah, it's ARM v7, I believe. Docker Arch for Raspberry Pi. Maybe build. Ah, yes, and I have already been here. And yeah, here's the basic thing. Notice how it's like Docker buildx build these platforms. So I think we want to just snag all of these. Notice how here's Linux AMD 64. So like if we were to run on, you know, my desktop computer, this is what we would run it on. But then we've got ARM v7 and ARM 64 v8. That's what we care about. Let's drop that right there. And I want to run back over to... Look, I already had it open. I lose track of all the things I need to talk about. Oh well. And they're just comma separated, right? So there's that. We have that, we have that. Okay, so I think this is the only change we need to make. So what we're going to do is we're going to add that. Build and publish multi-arc/arch images to support Raspberry Pi. Okay, so that is pushed. And we can run back over here. This has a check mark. If I refresh, it has the dot. We can watch the magic run. Cool. And yeah, so we should hit all the caching layers right here. This should be really pretty quick. So we haven't changed any code. We'll find out if that's really true in a second. The other thing that, oh yeah, I see. So notice how we've got like Linux ARM64 for each of these. Linux ARM v7. Oh, so they're kind of like interlaced. Oh, cool. There. Okay, so I think it's running in parallel, and it's not like in lockstep. So I think AMD 64 is kind of caught up, or AMD 64 is ahead of everything. Oh. Okay, let's have a look at what just happened. Notice how this failed, so the whole pipeline in general failed. Let's see. It looks like ARM v7 falling back to source compile with node-jip. So in other words, we've got native C++ code needs to run. Oh dear. And then, I mean, this is all kind of the same. It's like this error caused all the other ones. And it looks like the actual error, like if it could have found Python, it probably would have passed, right? Python didn't exist, and so it couldn't compile a SQLite driver from scratch. And then this all explodes. Yeah. And then later jobs all just canceled. Okay, cool. So let's figure out how to get Python installed in these boxes. Or maybe like alternatively, we just need SQLite to support those architectures. So let's maybe go look that up first. So we are running SQLite 3. So let's go look that up. Binaries for most node versions of platforms are provided by default via that. SQLite 3 module also works with Node WebKit, which we're not using. That's a front-end thing. Yeah, we can build it from source. Ah, look at that. Depends only on libsqlite 3. However, by default, an internal bundled copy of SQLite will be built and statically linked. So an externally installed SQLite 3 is not required. Building against an external SQLite 3, make sure to have the dev headers available. Ooh, okay. So development headers, this could get hairy really quickly. I think instead, oh, maybe we need that anyway. Not really sure. Oh, but no, what does it say? An internal bundle copy will be built exactly linked. So that's fine. This is not required. Okay, so let's do the internal copy SQLite, but then we need Python as part of the installation. Okay, we need Python. Sounds like there's no way around it. We need Python. Unless there's anything going on. Oh. Oh, wow. Interesting. Including Raspberry Pi. So these are the development headers. Oh, no. This is SQL Cipher. And besides, this points to SQLite equals here. Yeah, oh, okay, never mind. That's not what we want. Too bad. Okay, so I think what we need to do is we need to exec into this box. What I mean by that is we need to run this Docker image. So let's do that first. Oh, I shut down Docker. Okay, so we're gonna have to turn that back on, and then we'll have to figure out how to install Python inside of it. I'm also realizing I'm dropping a lot of frames tonight, so my apologies for that. I need to upgrade some stuff. So this will start up. As soon as it does, we'll be able to do Docker run. It'll run, inside of the engine. There we go. Okay. So that's running. We can prove that's up by going here. Yeah. Run that. Dope. And then let's see. I forget how to exec into stuff, but I think so. Let me just do it. Let's try that. Oh, nice. That was really slick. So look at that. So we now have a shell that's like directly inside of the Docker image, and we can start to do cool stuff with it. So for example, we can say which Python and which Python 3, and it doesn't exist. Neither of them exist. So let's see, we're Alpine, so I think APK should exist. Can we do this? How do you use APK? Oh yeah, APK add Python. Or maybe we should actually let's do this first. APK list Python. Interesting. APK index? No? So, oh, there's an update. APK update. Okay. APK list Python. APK info Python. What happens if I just try to add? Huh, well shoot, how do you actually do this? To Google we must go. Well, stuff in some keywords. This is what I use. I don't know what this Python unbuffered means. Looks kind of weird. Look here. We're looking for the Python 3 and packages. Well, let's give this a try. Hey, that worked just fine. Sweet. And does that also... Okay, so it's Python 3 specifically. Yeah, let's figure out what's going on with no. A new no cache option. Index that is updated and used on the fly. Yeah, I like that. Cool. So yeah, I think this is our... Oops. This is the command we want. So let's grab that. And we need to put it in our Docker file. This is a run command. So apk add no cache, Python 3, py3 pip. So then by the time we hit this, Python 3 will exist and it'll be able to build SQLite. It'll be able to build SQLite from source. Let's try it. So I'm gonna exit out of there and there, come back over here. I've got this second tab that we don't need. I kind of do need it. Okay, let's shut this down. Hopefully get some CPU back. Install Python so we can build SQLite 3 from source on other architectures. Okay, so we push that up. And now let's close some things. Put this over here when we need it. And then we should be able to come back in here. Yeah, there we go. That's progress. And let's see if it works when it gets to the build part. Okay, cool. So here's the part where it installs Python. Looks like it did it just fine for AMD 64, so I think that's a great sign. ARM 64 also did it. Got truncated, but yeah, assume that worked just fine. Yeah, okay, good. This looks very promising. Now we just wait a bit. In the meantime, you know what we should do? Since I've got my visual aid, I'm going to keep using it. Let's plug this thing in. I don't have another camera, unfortunately, but it's just going to be sitting on my desk. So let's plug it into power right here. And you'll see it light up. There you go. And I'm just going to rest that on my mouse pad. And then, by the way, I'm still watching this. And this is the good part. I'm gonna fall back to build. You'll notice that the AMD 64 has already passed the server. It's going ahead with the UI. Oh! It exploded again. Interesting. So what is it complaining about? Make is not found. Huh. So this is gonna get hard. Like, we don't have a really good what's it called? We don't have a good feedback loop here. Like, very slow. What's something that we can do? I mean, we can just... I don't like the direction this is going. Build base, that could be a good one. If you're coming here from the future, you probably want to go here. Yeah, I think this is probably basically what we want. Use this. Oh, that's kind of cool. I don't think we need it. Yeah, APK add, build base. So let's see, what's this other stuff? Build base, GCC I think we will want, wget maybe we'll want, git maybe. Let's just do those though. And I'll put them kind of in order from like lowest level to highest level. Build base and GCC, I think that's all we need. Let's just do this for now. Okay, so that'll do its thing. I don't think we need to babysit it this time around. So let's actually SSH into that Raspberry Pi as the other thing working. Now, if I remember correctly, yeah, cool. I can get into my Raspberry Pi, and sure enough, it's working. Look, there's my local IP address. You won't be able to. Okay. I love my LL command. That's just ls with a whole bunch of flags that makes it look nice. It's human readable. It's shows owners. It shows lines, whatever. But at this point, yeah, I should have. Oh shoot, we don't have Vim yet. Let's just go get Vim. What is going on? I am not root. Okay, now I'm root. I would really like to have Vim. I want it. And remember, we're looking at this on our computer, but this is really SSHing into the Raspberry Pi. So this is all happening there. And now we can vim get docker.shell, which is right here. Yeah, Docker told me to do it this way. So I believe Docker already exists, which is perfect. Okay, let's run back over to here. Here's the latest action. You're building. Oh, it looks like it just failed. It's too bad. Okay, well, so it goes. Python not found. But I thought it would fall back to Python 3 if Python was not there. So here's all the places where we installed Python 3. We don't care about those. Huh, it's not referenced anywhere besides that though. Okay, clear that out. Okay, well, maybe we just need Python then. Let's try this. I think when it builds, it's got like a different index file, so we're able to just do that. Python, nice. 2 instead of 3x. Okay. That'll build. We'll let that sit for a while. So back over on the Raspberry Pi, let's see. I know the IP address of the Raspberry Pi on my network. I can get that from my router and stuff, and it's in my etc hosts file. We also just kind of need an easy test. Ooh, the other thing that we could do, I'm very curious what happens if we just like grab this. Well, okay, we'll have to change some stuff. On Raspberry Pi. So let's do like, where are we? Home Pi. Light blocks DB. So this is going to be our database directory. Set up all these other things. So let me just try running this as is. I think it's going to fail. Oh wow. So it is downloading it. I'm wondering if this is still gonna fail though, because like we built it for a different architecture. We built it for AMD 64. Because Raspberry Pi should be ARM v7. We're about to find out what will happen. Okay. Meanwhile, son of a gun, it still failed. It failed in 11 seconds. Python, there's no such package. Well. Python 2? Flagged. The flagged, I think flagged is deprecated. Okay, so I guess we just named it the wrong thing. Okay. And let me be clear, this is me kind of being lazy and not wanting to like start up Docker locally again, because that was like killing my computer and the stream. I did. Wait, it's still running. Well, the Docker daemon is still running. Okay, if this doesn't work, we will actually do it locally. Well, maybe not, because, I mean, it's just that architecture that fails, so we probably still have to do it this way. See, I'm not lazy, I'm just a pragmatist. So, back over to the Raspberry Pi. Looks like we are just about finished setting everything up. Notice how you can see each of these layers one by one. So this is probably the Alpine image, and then like each of these is, you know, workdir and npm install and all that kind of stuff. And so we're extracting each of these layers, and the layers will apply on top of each other. And that's what all this is doing for us. Also, while this is doing its thing, I don't know if you can hear it, but I can at least right here hear the fan going. It's this kind of high-pitched hum. Okay, the requested images platform does not match the detected host platform ARMv7, and no specific platform was requested. Oh yeah, that's fine. Okay, and so it exploded. Okay, it downloaded all the things, and then it finally decided that it wasn't going to work. But that's okay. I basically expected it to fail, so this is cool. I'm not even mad. But I might be mad if this doesn't work. I would really like to see this succeed. The other thing that I do need to do, though, at some point, while this is running, remember that 3 of these environment variables that we're going to rely on, those are all credentials that are like my real home network talking to my Philips Hue bridge so it can control the lights. I'm going to need to copy all of those over into the Raspberry Pi. And I'm going to have to do that without all of you seeing it so that I don't like stream my credentials. We can do that in a minute though. So I'm puzzled here. It's not showing me output from here. Did it just run away? Oh, here we go. Okay, this right here is the moment of truth. One comment again about Docker image caching. We keep making changes down here, and every time we make changes to a lower level, it invalidates all of these other later layers. And so we're making everything take a long time. But eventually, once we figure this stuff out, we're not going to touch this. We rarely touch this, which means that this stuff will be a lot faster. Okay, that is still doing its thing. Here's what I'm going to do. I'm going to switch over to my camera, and I'm going to do a little bit of typing here without y'all watching. So I'm creating a .env file, and I am pasting in my credentials. Make sure that's there. And yeah, that's all there. Cool. Hide that. Okay, sweet. so I copied the credentials over. We're back. But now, notice how here's my home directory, and there's this new .env file. And I've typed source.env, so now that's part of my environment. And so when I go to run this, it will actually pass all that stuff through. Okay, back over to here. This looks like an error stack trace. No, these are just warnings. Oh, look at that. I think ARM64 is building from scratch as well. Or wait. Oh, no, ARM64. So we're seeing this and this. I'm guessing that this didn't need to build it from scratch, though. Okay. So it's slow. I mean, like, notice how we're 5 minutes in. We only got to do this once. It only needs to succeed once, rather. And as soon as it does, boom, we won't have to touch it again for a while. And that'll be sweet. Trying to think if there's anything else we can do in the meantime, though. We can try running like another Docker image on a Raspberry Pi. That might be a really good thing to do. Yeah, I keep just coming back to it. Let's do it. So we'll go over to Docker Hub. Look, here's my other stuff. You can see some private ones. I want to run Nginx. Nginx is like a really easy one to get up and running, I believe. And in fact, like, yeah, I think we don't need to do that much. Let's start like from here, on Nginx on Raspberry Pi. And what we're gonna do, I want that. What port does it run on? 80? So container port 80, host port 8080, I like that. We're gonna skip all these. We don't actually need that, and then we'll just say Nginx. And in fact, we can try this out locally if we want. Yeah, but that should be up and running. So now I should be able to go localhost 8080. And sure enough, I'm running that on my laptop. Optimistics Williamson. Let's shut that down, and then over on the Raspberry Pi, I should be able to run the same thing. So it'll download. You can see it is not as fast as my laptop. It's struggling a bit. Okay, we're gonna run back over to here. Still going? We're 8 minutes in? Yikes. You know, a watched pot never boils, and a watched CI pipeline never runs to completion. That's what my dad taught me. I'm just telling dad jokes now. Like, we need this to finish so that I can stop making a fool of myself. Good times. Like, really, CIA is the sort of thing where, like, you don't really want to tinker with it. Like, you want to get it set up, and it's kind of tedious to do it. But as soon as it's set up, you can kind of forget about it, and it just makes your life easier after that. So as tedious as this kind of is right now, like, it's really going to be nice as soon as this is working. So I'm pretty pumped. Yeah, and like I feel like we're close because like we're seeing actual compilation happen in the logs, and it's generating like compilation warnings from the native code. But like I see that in all sorts of open source projects that I worked on and that I've like downloaded. So I'm not really worried about it. I think it's gonna work this time. So let's run back over to here, back to the Raspberry Pi, and this output looks the same as what we saw on the laptop. So I think we can do this. Yes. Okay. So you'll notice Raspberry Pi is a named host that I've given it, and then port 8080. Yep. That's connecting into port 80 of the container port and serving up the generic Nginx welcome page. So that's pretty cool. We can shut that down. Now if we run back over to here, boom, it didn't connect at all. But it means that the Docker daemon is working correctly and we're able to actually run Docker images on the Pi. So that's great. Now we just need this bad boy to work. And then we will be up and running. Yeah, we'll keep that thing around. I think I'm gonna just nuke some of this other stuff. I think we're fine. Let's see, it's there. It's all doing its thing. I would like to know why I don't get to click on that anymore. You see how that little like caret is gone. I wonder if that means it's generating like so many log lines that it doesn't want to show them. Try this. See, this is like way behind. I think this is just like the first 4 lines of the whole thing. Oh, here we go. It's catching up. These are still just warnings. Crazy slow. Ooh. Can it be? No, I don't think so. I mean, I can see database.o. Like, does that mean it's final output? I don't know. Just making gradual progress. This is ARM v7 that's saying this, yeah. It's... Let's see, question from chat. I think you touched a bit on this before, but at what point do you worry about warnings? Yeah, that's a cool question. So, some thoughts on that. We've got our code, like our first party code that belongs to us. We wrote it, and it might produce warnings or it might produce errors. Those matter a lot to us. We never want to have errors. And really, if we can help it, we don't want to have warnings. In fact, this is a policy that my coworkers and I have at work, but we actually set up our compiler settings so that if there are any warnings, then they're treated as if, oh, look at this. It just finished. It passed, like it successfully built. Okay, sweet. So we actually have it set up so that compiler warnings are treated as if they're compiler errors, and so it breaks the build. And what I mean by breaks the build is the continuous integration pipeline is going to turn red rather than green. Like even just a single warning that's like you missed a curly brace, or not a curly brace, you missed a semicolon in JavaScript, which like doesn't actually need semicolons. You missed one, the linter tool doesn't like it, so that warning, you know what, it broke everything for you. And that helps us keep quality high, because if you let even just one error or even just one warning through, it has a tendency to like create more and more and more, and that terminal noise starts to kind of compound on itself. And so you really want to avoid that, especially if you've got like other people working on your team or you're doing open source. That's important. So now third-party code might produce errors or warnings. If it's producing errors, it's probably because it's not configured correctly. Like it's at least likely that somebody else is hitting the error before you are, especially if it's like a very large project. Not guaranteed, but like chances are somebody else might have already bumped into it. They might have already opened an issue on GitHub or somewhere, and you can kind of like pick up where they left off, and you might be able to like learn from whatever their mistake was in terms of configuration. Warnings, though, for whatever reason, I swear this is like C and C++ culture. I just see a lot of like compile time warnings that often have to do with kind of nitpicky things about like case statements, or no, what are they called in C++? Switch statements. Elixir has case statements that are sort of similar. But I think some of that might have to do with like different C compilers. Like, oh, their core team usually uses Clang or Clang when they compile, but like you happen to be using GCC or vice versa, or they use some different compiler flags. You're building it from source with different compiler flags, or you left off the ones that they normally have, and that's because like you're running a tool that's compiling, their thing, but there's like layers of abstractions in between. Like, I mean, like we've got a JavaScript project that relies on Python as a build tool to do some configuration for C++ code for the database itself. So like there's all sorts of abstractions happening in between our stuff and the like lowest level library that actually interacts with the SQLite database. And so I would say in situations like that, compiler warnings don't matter as much. When it gets closer to you, the warnings matter more. Yeah, so those are some thoughts. Yeah, let me know what your thoughts are if you got other questions about that. Really, really good question. Good things to think about. So here, let me show you where the output is at this point, and you'll notice that we've moved past the npm CI commands with ARM64, with ARM v7. I think AMD 64 is like long since finished. But this is great. Like we're past the hard part. Now we're just compiling our first party code. And so yeah, creating an optimized production build. This is the part that tends to take the longest when we don't have to worry about system dependencies. In other words, like when we're not fiddling around with this is the slow part, especially this. So I think it's just a matter of a little bit of time. It's probably like another minute max. And then we should be good. It'll get pushed up automatically, and we'll be able to pull it back down to the Raspberry Pi. Now, let's see. As this does its thing, run on tag. I want to go look this up. I don't think we need to do it right now. But do you remember how I mentioned that, and here, let's maybe pull these up side by side because we keep talking about both. notice how this workflow is getting run on a push to the master branch. So whenever that event gets triggered, we're going to end up running this thing, right? So there are other ways that you can configure this so that you don't run it every single time you're pushing to master. You can just do it every time you make a tag, and that's nice because then you can do things like, and let me maybe illustrate this here with the history. Let's see, how do I do that? I use GitLab at work, and so I like don't know the GitHub UI very quickly. So here's like the history, right? And you see how like I've got a bunch of commits in a row that are like kind of a mess. And if I were doing a feature branch, then I wouldn't have all this problem. But since I'm tinkering with CI, CI tends to create these like nasty commit blasts. So that's just kind of too bad. But basically, I might want to say like, well, this is version 1, or maybe more specifically, like if I'm using semantic versioning, this is version 1.0.0. And then let's suppose this passes and succeeds and all that good stuff. Then I want to tag this as version 1.0.1. So it's a patch release. But I don't care about everything in between. What that means is I don't want CI to run in between. Like I don't want these to do all that extra work and create a bunch of console noise and possibly like slow down other work that's getting done concurrently. And so it's a nice idea to kind of tune that. And the other thing that I don't want to do is I don't want to create a whole bunch of images that are pushed up to Docker Hub that are like fluff. Like this is a useless image, this is a useless image. Even if it did pass, like, you know, who cares? It's not useful. And so really I want this to be an image that exists, and I want this to be an image that exists. And so basically we would move away from the latest tag. Actually, we would keep the latest tag, but we would say like, you know, when we build this, we're going to say this is adj90/lightblocks, tag it as latest, and tag it as 1.0.0. So that happens here. Skip a few, and then when we hit this, we'll add another git tag that's like 1.0.1. So we've done a patch release. That gets picked up and ends up being pushed as another Docker image, which will be adj90/lightblocks. Also tag it as latest, so it takes that tag away from the previous one, and then also tag it as 1.0.1. So why would you want to have one static one with with a version number and then another one with that's like constantly moving? And that's because you've got different consumers of your code that have different requirements. So if I'm just having fun and messing around, I'm like, oh yeah, just give me the latest version of adj90/lightblocks. Like, I'm not thinking very hard about like which version my enterprise needs to run, because I'm like turning on some lights at home, you know. But on the other hand, if I'm at work or if I'm doing research or whatever, I probably want to pin to a version that I know is good and I know is not going to change on me. Especially is not going to change on me in a way that has a breaking API change. And so, yeah, I had to run over to here. Actually, let me just check this really quick. Oh yes, we are so close. So this is semantic versioning for those that are not aware of it. This is like a beautiful kind of gem of standardization in the modern world of software. But what it basically means is your software, if your software happens to be following semantic versioning, because not all software does, make sure to check when you install something. Basically, you've got major.minor.patch, and you basically say, I'm going to change this number whenever you make incompatible API changes. So like there's a function that works differently than it did before. Or you know what, there used to be a function to do XYZ, but it's just not even there anymore. So that's an API change that is now incompatible with whatever you used to have. So that's a new major release. Then minor, when you add functionality in a backwards compatible manner. So in other words, like there's a new function. The old functions are all still totally there. Like there's nothing Nothing is broken about that, but there's like extra stuff if you want to start using it. And then patch when you make backwards compatible bug fixes. So it's like, you know, there are no new functions, but I realized that that existing function, it had a problem. I fixed the internals of it, but you still interact with it the same way. So as far as you know, it's the same. You just happen to get like a bug fix or maybe a performance upgrade or maybe a security fix. So that's what that's about. And so what that means is when you publish Docker images that match this semantic versioning, your consumers can look at this and be like, oh, you know what? I want version 1 point something. But if version 2 point something comes out, I'm not quite ready to use it. I'll probably need to go look up like the changelog document in order to figure out like what that'll actually do. And that's so useful. Like it saves from just countless nightmares. I mean, like, I think this kind of sums up what you're trying to avoid. You know, there exists a dreaded place called dependency hell, and you want to avoid it, and this is like an amazing way to do that. So anyway, eventually we can move towards semantic versioning with light blocks, and that'll be a really nice thing to have. But before we do that, check this out. We have successfully built all the things ever. Looks like it took 23 minutes total. So thank you very much for bearing with me and hearing my dad jokes and hearing me stall for 23 minutes. I guess we got some good things done in the meantime. But this should all be pushed up now, which means I think... did I close Docker Hub? I think I did. So let's go back over to there. And we should be able to see it. I actually... Full disclosure, I have never done a multi-arch build before, so I don't know exactly what this is going to look like. Yeah, so it looks like if you click on light blocks, you can see it list like each of the architectures. It was pushed at the same time. They're slightly different sizes. They're not like crazy different. Also, I would expect AMD 64 to be smaller, but it's actually a little bigger. So that's kind of interesting, but I don't think it really matters. Like, they're not materially different in size. Okay, so now, the moment of truth. Oh my goodness. Please work. Okay, so I think what just happened here is it already had the image installed, and so it didn't go and fetch the new one. Sorry, let me go back really quick. Got another question in the chat. If an API remains backwards compatible, would the major version never change? No, it would not actually. So you could stay on 1 point something forever. You totally could. In fact, a lot of programming languages do this. So I know like the Elixir programming language is just I think it's 1.12 right now, soon to be 1.13. The Rust programming language is 1.53. Like, you've got a very high number for the minor version, and they're very careful not to make incompatible changes. They don't strictly follow semantic versioning. They have this idea of Rust additions, and so eventually when they remove the 2015 edition, then they'll go to V2, I believe. I guess we'll have that. But the short answer to your question is no. You could totally stay on 1.x forever. The other thing you can do is you can start at 0.x, and that's considered unstable. And so if you make any changes at all before you get to 1.x, all of those are considered breaking changes or possibly breaking changes. And that basically means like this piece of code is not quite ready for prime time yet. So like use it with caution, maybe don't use in your big old enterprise org. But like it's ready to be like start to be used. It's like an experiment that's being validated. Cool. All right, so let's do this. Yeah, and you can see we've got like all these images. I think I want to say Docker, I think it's Docker RMI, if I remember correctly. And I want to just delete that. It might make me force it. Let's find out. That's being slow enough. It probably did it. Yeah, okay. So now if we list, that's gone. Cool. Okay, so then let's run back over to here. Copy. Whoa. I think I've scrambled up my standard in by working too quickly. All right, paste, enter. There we go. Yeah, so notice how it couldn't find it locally because I just deleted it. We're gonna download the layers because that very, well, I guess one of them might have been cached. Looks like it wasn't in this case. But I mean, like, since we changed this very low level image, we're gonna have to go fetch it. No, that's not why. The reason we had to pull every single layer is because we're in a different architecture. So I am really hoping that this is just like fetching the correct architecture. We might have to specify it in the arguments. You know, like we might need to like somehow like platform equals something. We'll find out in a minute. Oh, that's not good. I hope it doesn't time out. But basically, this should be able to like locate the right architecture and then go from there. There we go. It's going slow, but we will get there. Okay, that's really going pretty slow. My poor little Raspberry Pi. I'm actually suspicious of the SD card. I think I might have bought an SD card with sort of a slow transfer rate. It's not like crazy slow. I want to say it's like, what is it? Yeah, up to 98 megabytes per second. Asterisk. Here's the thing. Oh, that's the read speed, write speed slower. 1 megabyte. Huh. It doesn't give me any kind of promises about what the write speed should be. But my guess is that's what's happening, is like we might just have kind of a slow SD card, and so the operating system is having a hard time interacting with the file system. On the other hand, like there should be enough RAM. So I don't really know. The other thing that it could be is like it's this very small box physically, and so it could be like overheating a little bit. I don't know. I haven't done like really heavy like CPU intensive stuff on it. So maybe I'm just gonna open up this box carefully so I don't like screw up the GPIO pin. Set this down here. And so now I can just like air out in the room. The heatsink, like I'm touching the heatsink. You can't see it, but I'm like touching the heatsink and it's a little warm, but it's not like crazy hot. This looks to me more like, I don't know, it looks like my SSH session is just dead. I'm gonna kill it. Okay, I'm doing Control C and nothing is responding. A very bad sign. Oh, hey. Well, I'm gonna log in again. It's kind of nice to have two sessions. I don't know. Let's run this again. Why is it re-downloading everything? That's dumb. It's probably because it couldn't commit anything because the command itself failed. Too bad. We're making slow but steady progress. Got up to about the same place. Looks like we're past it now. That's good. And this is where like a video kind of shines above a stream because you're not waiting for downloads to happen. Like you just kind of jump cut past that. So thank you for being patient while this download stuff happens. This really is like, you know, a fair amount of like, you know, publishing software or like making sure that the integration type stuff works. Just kind of like relies on some like tedious stuff like this. It's worth it in the end because like this is the step of the process that actually gets the software out into the world. If we were just like, you know, if we were just doing this on our own computers all day long, then like it wouldn't matter because it would just be in a vacuum. So when this stuff works out, like that's when it becomes magical because somebody can actually like benefit from our work because I don't know, it becomes like a lot more real. So it's cool. I'm doing my best to like say nice things about this like really kind of boring step in the process. Which I think maybe is a good opportunity to talk about like the next couple streams. So I think, you know, assuming we can get this bad boy working tonight, I think we will. Oh, here we go. We'll talk. We'll talk in a minute. Okay. Fatal error in blank, comma, line 0, unreachable code. Failure message object that. So this is gross because I'm not even sure what produced this message. Like it could have been Docker as it was building. It could have been Docker as it was running. It could have been Node. It could have been SQLite. Man, this could have been a lot of stuff. That is not very fun. So one thing that we can do is we can rerun it. We'll skip all the poll stuff and it should be quick. We'll see if it happens again. Yeah, and it does. Okay. So now we Google. Well, and I think there might be like a verbose mode. I kind of want to try that first. So Docker run reference. Great thing to bookmark. Is there like a verbose mode? No? Debug? Okay, so there's not like a debug. What else can we do? We can exec into it, I think. Let's try to do that. No, we can't exec into it because it hasn't started yet. There's that. Well, can we do... I forget how to do this every time. Oh, okay. So let's do like Docker run interactive AJ90 light blocks bin shell. Hey, look at that. Oh yeah. Okay. So we're snooping around, we're seeing what we can do. This is the command that gets run. Okay, so it's definitely that produces it. So I am very suspicious that this is SQLite that's producing this. I wonder if there's an easy way to prove that. Like, this might be really gross, but we might be able to just start diving into some of this. I mean, like we could, yeah, here's connect to DB. So you could put like a console log in front of it. And I need my LL command. I'm just, oh, it didn't recognize G. That's right. Okay. Server dist. Let's make a manual edit to app.js. Oh gosh. Oh no. This will be hard. Let's see. And yeah, I'm not good at VI or Vim. My apologies. Let's see. This is where we want to make an edit. And we're going to say console.log hello world. And then right here, connected to DB. And my hypothesis is that we will see this, but we won't see this. Okay, so we're going to run this command once more. Did it? It didn't even show me hello world. Holy smokes. How about we do this? So what we're doing here is we're saying like, execute a manual instruction in Node rather than a file. Oh, look at that. So what this is telling us, I don't know if node help works. No, node help doesn't either. Okay, so what this tells us is that in whatever way that we've installed Node, it's corrupted. Like, it's not our program's fault, it's actually Node.js that's just scrambled up. Okay. Cool. So here's what that means practically. Our Docker image is no good. We're gonna have to make a change somewhere in these first few lines. It's probably this, like this Alpine image is probably somehow not compatible. Like we probably need like a, what is it again? ARM v7, you know, Raspberry Pi, you know, like we need some kind of suffix on this base image so that architecture is working correctly, I think. Or else we need a system dependency that's different. I don't think it's this line that's the problem because this should just install over the top of Node. And remember that like when we just say node -- help, like we don't really care about these system dependencies. That's my hypothesis anyway. So if we got to build a new Docker image, like this is going to go multiple hours long. I don't think it's worth our time to like keep doing that. So I think this is going to be another one of those like Julia Childs moments where like on the stream, we're going to find a quick way to kind of get around this. I think what we should do is just install Node locally on the Raspberry Pi and then like clone the repo down. We're basically following option number 2. I think that'll be just fine for tonight. We'll be able to prove that the Raspberry Pi can run the server and all that good stuff. And then later on, you know, by the time you're watching this video in the future, hopefully this will be like the Docker image will be all ready to go and it'll work awesome on Raspberry Pi. Once it does, I will mention that on the README. I'll be like, Raspberry Pi is supported. So look for that. Look for that message. Here, I'll write it here, but not check it in, just to remind myself. Yeah, and in the meantime, let's go crazy and install Node. So here's their official site. You go here. Oh, Node LTS is 14.x now. I'm behind. Okay, fine. I will get updated on 14x. What is it? It's ARM V7. So let's see. We want to copy link, and we will say wget that. Downloading the tar file. What is xz? How do you unzip that? Oh, maybe we could just do this. I would rather just do that. APK? Alpine? Please? I want to say that there's like a node source. Well, let's try this for now. Extract. Can I just do that? Let's try. Yes. Yes, I can. Oh, wow. It's just right here. And there's Node. And it's version 14? Okay. That's pretty neat. Ooh, XZ is great. It has a super high compression rate. That is good to know. And I guess tar is compatible with it. Are there a lot of other things that are compatible with XZ? We've got that. We need to add Node to our system path. Okay. Filter the archive through XZ. Cool. Awesome. Yeah, thanks for the tip. Okay, so let's do... Oh gosh, I forget how to do this every time. I think there's probably... Is there a bash RC in here? Yeah. I need to make an edit to the path. This doesn't make any changes to the path. I think it should be export path equals path colon node something. What's going on? I'm wondering why it's not auto-completing. Home, by... Yeah, we'll just do that. Okay, cool. And now Node is on our path. So now... If I git clone this thing, should be able to do that. Run over here. Let me down today, Docker. Very disappointed. Do that. I'm gonna switch back before I forget. I might not have git. Okay, here I don't. What? Oh, we got a sudo apt-get update and sudo apt-get install yes git. I guess if we wanted to, we could download like the zip file of the repo, but I think it doesn't hurt too much to install git too. Like it's 13 megs worth of files. Too bad. And it'll bring in a few other things. I don't really care. This is my dev Raspberry Pi, so it can have dev things like Git. All right, cool. So there's Git. Now I should be able to run git clone. Here we go. All right, and now I should be able to say bin/build. And remember that, let's see, where did I put that? Yeah, so we've already done step 1, right? I did that on my laptop and then copied it over. And then step 2, we're not going to do option 1 Docker, we're going to do option 2 compiling locally. So we just say bin/build sh, bin/run sh. And so currently, this is what we are running. See where it's at. Building the UI, all that good stuff. And then I'll build the server. This is the npm install for the UI. So, since we've got a little bit of time here, let's talk about the next things that this stream is going to do. So, my plan is for this to be the final stream for Lightblocks. I think it's in a good place. If other people are interested in trying it out, like, please feel free to like clone it down, run it at home, contribute back. I'm planning on like putting a contributing.md file up pretty soon, so that like you'll be able to, you'll be able to participate a little more, because I think it's in a more or less stable state now. There are other blocks I want to add to it as well, but I don't think that'll be on a stream. I'll just like mention it when that happens. But I want to start doing some other stuff on the stream now, that might be a little shorter. So 2 of the things that I want to do, I want to do some scripts. Let me show you what I'm talking about. So Scripts is a video game. You play it on Steam. So it's a desktop game where you actually, I wonder if we've got like a cool screenshot. I don't know. Basically, you write code. Here's an example of everything running together. So you can see how like the game is happening up here, and it's a strategy game where you've got all these little creatures, little robots called creeps. They can move around, they can harvest energy, and they can store it, and they can do stuff. But it's an MMO strategy game, so that's weird in and of itself. Like, you've got all your neighbors. This is called a room right here. But like your neighboring room might have like an enemy person that's got their own little colony of Screeps. But the other really crazy thing about it is you'll notice this panel down here, like it looks an awful lot like an IDE. You can actually write code down here, and that code gets executed about every 3 seconds. And your code controls your little Screeps empire. And so I've been playing it for a couple years. I got really into it about 3 years ago, and then kind of put it on pause, did other stuff. Recently came back, and it's been a blast, like coming back to it and remembering where I left off. I know more things now than I did then. Like I'm better at some things. I'm a better programmer than I was 3 years ago for sure. And so I'm coming back to it now, and I'm automating a lot of things. Like, my goal is to be able to play this game in like a fully automated way. So you basically like, pick a place to start playing the game, and then you upload your code, and then the code should just do everything, absolutely everything, with no manual intervention. That's kind of the goal. And so I want to stream that every once in a while. I don't think I'll put it on YouTube. I don't think it needs to be videos, but I think it'll be fun. So you can see that from time to time on Twitch, and I'm hoping that that'll get some like cool engagement, because I know there's some people on Discord and Twitch and stuff that follow Screeps. So yeah, look for that. The other thing I want to do is generative art, and there are all sorts of different ways we could do generative art, but that's nice because you can like settle in for like a 2-hour session and like create a piece of art and then call it good, or like you can end up like the feedback loop is faster and it's really gratifying, and it ends up looking really nice, So those are kind of the 2 things that I want to like be doing next, is like Screeps and generative art. It should be really cool. So stay tuned. If you're coming from the future and you're watching the YouTube video of this, yeah, check it out on YouTube, streaming on YouTube, or check it out on Twitch. And I'll drop links to all that stuff. But yeah, thanks for supporting and checking it out. Back to here. So I see building the server. Looks like the UI finished just fine, so that's awesome. Now I am noticing we've got to go build SQLite 3 from source. That is, hey, and a lot of these warnings look familiar, don't they? This statement may fall through. Yeah, you bet. Fine. Ugh, but yeah, eventually this will work great. Press enter some. And having a Docker image, like this is yet another reason why it's very nice to have a Docker image, because if you got weird quirks with like how your system dependencies get installed, you can just hide all of that away. Like whatever crazy stuff has to happen, you just do that in the Docker image, and then the consumer never cares. Never knows, never cares. I've even seen people use Docker with like pipeline type stuff. So probably doing like data analytics, doing scientific research, doing a little scripty stuff. Like I've got a coworker that used a Docker image to generate diagrams from text, which was really cool. Let me see if I can find that. Yeah, he found a Docker image that had plant UML, and plant UML is very cool. It lets you write in text like this, and then this text turns into an image. And so you can actually create diagrams through this, through plain text, and then check it into source control so that as your code changes, your diagram can also change. And then you can have a script that you just run as you make changes, or you can even run it in CI, right? Like with GitHub Actions. And so your diagrams are always up to date. Like it's so easy to make a change to your diagram, because it's not like in, you didn't create the diagram using like an app or a website or something that like you have to log into or even pay for, or like give somebody access to that's far away from your code. So that's really cool. So the thing my coworker did is he found a Docker image that is able to execute this internally. And so, that's amazing. It just live updates. So, yeah, he found a Docker image that lets you do this without like installing anything locally. And that makes it really practical to, work on whatever code repo you're in and whatever that needs to install. But just focus on that tool chain and all this like peripheral stuff for like install the diagramming software. Like you don't actually have to do that. Docker just does it for you. You just install Docker, and then Docker hides all those other details, or that Docker image, hides all those other details. Oh, okay. Looks like we're finished. Cool. Okay. So we did bin build. Now we need to do bin run. And so this is the moment of truth. Okay, we're running in production. Permission denied. Yeah. Okay. So what's happening here? I didn't get a chance to test this before the stream, so this is my bad. But basically, I added some lines here. That's like, hey, if we're running in production mode, save it to here, because surely we must be running it in a Docker image. But that's not necessarily true. We might be doing local compilation, in which case this doesn't exist. But we can create this right now. We can just say sudo make dir /db, and we can say sudo chown, oh shoot, pi? Sudo chown pi /db. And so now we've got db that's owned by pi. Okay, now I think we should be able to run this. And yeah, we were able to connect to the database. And we initialized the environment, which means it found our lights. We're listening on server port 4000. Holy smokes, you guys. That's cache, by the way. Okay, Raspberry Pi 4000. Ho-ho! Oh, sorry, I just maxed out the ho-ho! Ho-ho! Guys, we did it! We actually ran the server on a Raspberry Pi. It actually is alive. Wow. After the long journey, we were able to do it. Okay, let's create a program. My dope program on the Pi. What just happened? I don't think that saved it. Shoot. Seeing cross-site, cross-origin problems. That's weird. My program. And look at that. We failed to make it. Blocked? Why was it blocked? Tell me. Horrors failed. Okay. NS error. Bad URI. Okay, you know what's going on. Yeah, we haven't dealt with this yet. So let's see, where are we doing that? Constants, we say that the server host is here. So this, for like, you know, run program, it's server host /API /interpreter, whatever. We actually don't want anything in front of here. We want it to just start with /API. So what we should do is we should where do we, yeah, there it is. We can find that here. Process.in.node_inf equals production question mark. Then it's the empty string, otherwise it's that. So basically we're saying, like, if we're just running this locally in dev mode and hit this, otherwise we're in production mode, then the UI and the server are running on the very same host, and we don't even know what that host is, right? It might be localhost, it might be Raspberry Pi, it might be an IP address, it might be like, I don't know, somebody's website, if we set that up eventually. So we needed to say this. Okay. Which means we need to make a code change. We're not going to push that up yet. We're going to push that up. Let's see. We're going to fix server. What is that called? Server host in production. So that gets pushed up. CI is going to run, and it's going to create a Docker image. We don't care about that right now because we're just doing local compilation. So what we're going to do, this should be a Git repository. Yeah. So we'll say git pull, and it picked it right up. There we go. So bin/build.sh. And this should be pretty quick, right? Because we've already downloaded everything. Oh man, we should maybe change. Let's change this to npm CI, because that'll be much faster. Because right now it's, you know, doing all the things. But let's see. Looks like we're done with the UI. Oh, well, we're, okay, we did npm install on the UI. That'll build, that'll take a minute. Yeah, that has pipe fail? Yeah, good. Let's commit that. Also, we only need it to run on the UI, don't we? So let's kill this once it's finished with the UI. So we're gonna say install in CI mode for performance and stable dependencies. There we go. Oh, and look, the server part was super fast, so we couldn't even catch it before it was done. Cool. All right. Here we go. Initialized. Fresh. That all looks healthy. Good, we got a 200 response. Edit it. Click run. And the lights turned on. Whoa. Okay. My friends. We did it. I'm gonna just poke around a little bit. I should be able to do some cool stuff. Switch over to this. Yeah. Did it. All right. And now, of course, we need to do... Let's see. Turn the light on. Maybe we shouldn't loop forever. Maybe we should just loop some times. We're gonna loop 10 times. Oh, and you know what we've also got to do? You already know this is my favorite block. We probably don't need this either. But we will turn all the lights off together. But we're gonna say set the color to something random. You'll notice we're also like blasting edits. We can change that in the future too. But we're gonna set color to a random hue. And you know we gotta turn off the lights for this. We have to. %, saturation, 100% brightness. Okay. Trash that. Trash that. All right. Give me a second. All right. And now I present to you light blocks version 0.1.0. Here's light blocks. Chill vibes. Yeah. Let's do that again. I think we've earned it. We've done a lot of waiting. We've sat through a lot of CI pipelines, a lot of npm installs. We had to worry about system dependencies. All that stuff was boring. But now, we get to enjoy chill vibes. Yeah. Okay, I'm gonna turn the light back on. Okay, that was awesome. Wow, we did it. Yeah, running back over to here. Here's what the program looked like. You can see it over here. Made some code changes. I don't know. I'm gonna check that box, but not this one. We'll come back to it. Don't worry. Here's that guy running. We should also be able to kill the server. That's off. Run it again, and it'll start right back up. Yeah, and my program is still there. Looks the same. Perfect. Okay. Friends, thanks for being a part of this. Thanks for helping out with light blocks. Remember, you can download it at GitHub. Let's drop a link to that just one more time. So here it is in chat. Yeah. This is so fun. Okay. Well, yeah. Thanks so much. So this is gonna wrap up light blocks, and we'll start a new project next time. Next week I'm not gonna be streaming, but I'll be back the week after that. But I'm Andrew. This is Code Gets Creative. Thanks everybody so much. See ya.